Hello there. So today's problem is word ladder. Word ladder, let's see what are the inputs for the problem. The input is a begin word, a end word and a word list. So now a begin word is a string and again end word is another string. What we are going to return is how many transformation it takes or the number of transformation it takes to convert a begin word to end word. Okay, what is a transformation here? Transformation is changing the word to another word by changing a single character. For example, hit is the word. Hit is can be transformed to hot by changing I to O. So by changing a single character and turning it to another string is the transformation. So now the transformation is valid only if the word is present in the word list. If not, the transformation is not valid. So like that we have to change each and every string to next level and then get to the end word. So this is the problem statement. Now the output will be 5. Why? Because we have changed the word or transformed the word to 5 different levels. 1, 2, 3, 4, 5. So that is the output we need to return. So now let's see. If you keenly observe this output format, from hit we are changing to hot, from hot to dot, and then to dog, and finally to cog. So now this represents edges and vertices, which is very similar to a data structure called graph. So now we are also going to use breadth first search to do our algorithm. Before getting into the algorithm, let's see what are all the possible transformations can happen from the word list. For example, our begin word is hit. So hit can be transformed to hot, lot, log and cog. This can be one path. The other path can be hit can be hot, dot, dog, log and then cog. So there are another different ways as well to reach to the end word. Let's get into our algorithm. The three major data structure or a variable we gonna use in our algorithm are queue, level and neighbor. Let's see what does a queue do in this algorithm. A queue is nothing but it is a data structure used to track our transformations. So for each iteration, the queue track at what stage the transformation is. And the second one is level. Level is our output in our algorithm, which is basically like I explained before. It calculates how many level the word reaches. For example, if it reaches level 3 and the queue is having the end word at its pole, let's poll the recent string from the queue, and if that matches the end word, level 3 is returned. So at level 3 the transformation is made. If not, the end word is not found, then it goes to generate the neighbors of the string. Let's see first how the queue works. As I said, our queue is used to track our transformations. At first, our first word will be, the begin word will be inserted into the queue. Next, the neighbor method populate all the neighbors of the word hit and then check whether any of the words are present in the word list. Let's see what are the neighbors later. First, the neighbor found is hot, so which is also in the word list. So hot is entered into the queue and hit is removed. And again at the third iteration, for hot, what are the neighboring words available in the word list? Dot is available, so we are removing hot. Hit is already removed, so dot and lot are the neighboring words for hot, so they are entered. Now the queue size is 2, and again so it will iterate for twice and find the neighboring words for dot and lot. So it will be dog and log, so other words will be removed from the queue. Now again the size is 2, it will iterate twice for the word dog and cog. The neighboring word for dog and cog is log is cog. So finally all the words are removed and the end word is found. The transformation is 5 and the value will be returned. So basically what our algorithm will do, it will take a word and find its neighbors that matches the word list, and it goes on until it finds the end word. So by how many transformation it goes, it calculate the levels and return the output. So let's see how the neighbors method gonna work. In our code we are going to have a helper method called neighbors to calculate a list of strings that are neighboring to that particular string. For example, here hit is our begin string. So hits, the neighboring string for the hit can be anything by replacing characters from A to Z. For example, we are removing I here and can be replaced with any character from A to Z. For example, hat or HBT or HCT and etc. The same way, H can be replaced by any character like AIT, BIT, etc. Similar to that, T can be replaced with any character. So what our neighbor method is going to do, it is gonna generate all the possible neighbors for the word hit, and then it goes and check in our word list any of these neighbors are present in the word list or not. So one of the neighbors can be hot. So hot is already present in the word list. So from these list, hot matches the string in the word list. So hot is the next neighbor that has to enter the queue. The same way, again for hot, the neighbor method is called, and for hot, the neighbors will be found, and the neighbor that matches the word list will enter the queue. The same way until it ends with the end word, the loop iterates and the levels will be calculated. Now let's enter our code in our LeetCode page and check how it works. So here is the problem page where we explained what are the inputs and outputs. Now let's enter our code. I am defining a queue data structure to keep track of the words transformed. And set to check the words in the word list. Why I am using a set is because set is having a constant search time. So whenever you want to have a constant search time, you can go for hash set. Now we are copying all our words from the word list to this set, so that we are using this set words to search with the list that is generated from the neighbors method. Now we are going to remove the begin word from the set, because the begin word is already the starting word, so you don't have to do the neighbors again and again. Like if hit, for the second word hot, hit will be a neighbor, so again word list will have a hit, and hit will be transformed from hit to hot to hit. That is an unnecessary transformation, so we are removing the word from the word list so that it won't be repeating in the progress or transformation. Now in our queue we are adding our first begin word as the first level. Now we are defining our result, that is level is equal to 0. This level increments every time there is a word added to the queue or every time a new transformation is done. Now we are taking size of the queue, because for that many, if we see if we see, for the first level it will be one word, for the second level it is again one word, for the third level there are two words. So this loop iterates twice to find the neighbors of both the words dot and lot. Here we are incrementing the level because every time a new transformation is done, a new level is formed. As I said, it iterates for how many new words added to the queue. Now we are taking the current word which is there recently added to the queue, because we have to find the neighbors for the recently added neighbor. If the current word matches the end word, then our output is done. We have to return the level. End word, then return level. If not, we haven't reached the word, then we need to find its neighbors. We are going to use a helper method for that. Helper method name neighbor. We are passing the current word because we have to find the neighbors for the current word. String name. We are iterating the neighbors to check whether any of the word matches the word in word list. So if words.contains, here we are using the set to search whether any of the neighbors returned from the neighbor method matches the word in the word list. Then we are removing the word from word list because we have reached that word. We don't have to hit that word again and again in our transformation like we did here. We are doing it again to remove the word, and we are adding the word to the queue because queue is used to keep track of the transformation. Okay. This number returns level here. If it reaches the end word, it returns the level. If we did not hit the end word at all and the loop goes, then it returns 0. Now let's spend some time in creating our neighbors method. What we are going to return is the list of string that are neighbors to the string passed here. We are going to create a character array and we are converting the string to a character array. and defining a list result, so that we'll add all the neighboring birds to the result and return it. As we explained the neighbors, we are going to take each character from that string and replace it with all the characters from A to Z. For that, in temp we are going to assign the first character. As the loop iterates, it is going to get the second character and third character. Then we are going to assign that in that particular place with the C, that is the characters from A to Z, and convert it to a string and add it to result list. And result dot add the neighbor. And again, for example, in hit, if we took H in temp and having I and T, AIT, BIT, CIT will be generated and added to the result. Now again we are going to replace H to the first place and take the second letter. For that, we are reassigning that particular character to temp again, so that once the loop enters again, it is going to take the second character and H and T will be same. So now we have added all the neighbors. We are going to return the result list. This list will go here and then look for whether any word that matches in the word list and add it to the queue. So let's run this code. Clarify and temp semicolon expected. Which line? Okay, I just misspelled it. Again, same mistake. So I have made a few uppercase lowercase mistakes. Now let's run our code. Yes. Yes, the solution is accepted. Thank you.